Welcome to the deep dive. Today we're looking at something that could seriously shake up the U.S. tech industry. Maybe it already is. It's all about rare earth minerals.
Right. Things most people don't think about day to day.
Exactly. But imagine, Silicon Valley grinding to a halt, not because they ran out of ideas, but because they can't get these obscure metals, and one country holds most of the keys.
It's a huge vulnerability,
Yeah.
a critical one. And what's happening now, it really could reshape American tech, even national security. It feels like a slow-motion economic hostage situation, doesn't it?
That's a strong way to put it. In this deep dive, it was really kicked off by something specific, right? Back in April 2025.
Yeah, April 2025.
Yeah.
China brought in export controls on 7 specific medium and heavy rare earths. Plus, and this is crucial, the magnets made from them. Powerful little things essential for, well, almost everything.
And this wasn't out of the blue. It was retaliation, yeah. For increased U.S. tariffs, we saw numbers like, 10%, 104%, even 145% on some Chinese goods?
Precisely. It's part of that escalating trade tension. And the timing was sharp. Around April 4th, those shipments just stopped. Not slowed down, stopped.
Wow. Okay, so that immediately jams up the supply chains for a lot of U.S. companies, I bet.
Instantly.
So our mission today is to really understand how deep this dependence runs, what are the actual consequences, the potential chaos from these controls, and maybe, just maybe, are there ways out? Any alternatives?
That's the plan. We're pulling from a range of sources here: PBS NewsHour, Fox Business, outlets like Bulgarian Military, Eurasian Times, Thomas Keenet for industry insights, expert analyses.
Right, and the picture they paint, it's getting pretty worrying.
It is. So maybe we should start with the basics. What are these rare earth elements, REEs?
Good idea. Because the name itself is a bit misleading, isn't it?
It really is. They're not actually that rare geologically. We're talking about 17 metals on the periodic table: scandium, yttrium, plus the 15 lanthanides. Chemically quite similar, often found together.
So if they're not rare, what's the big deal?
The challenge isn't finding them. They're quite abundant, but usually in very low concentrations. The real difficulty, the expensive part, is separating them from each other and refining them into usable pure metals. It's incredibly energy-intensive, complex chemistry.
Ah, okay. So the rarity is more about the difficulty and cost of processing them.
Exactly. That's the industrial bottleneck.
Got it. Now, why are these hard-to-get metals so indispensable? What do they actually do in our tech?
They have unique magnetic, optical, and catalytic properties that are, frankly, irreplaceable in many high-tech applications right now.
Like what? Give us some examples.
Okay, we'll start with a smartphone in your pocket. The tiny motor that makes it vibrate. Rare earths, the incredibly bright, vibrant colors on the screen. Rare earths, the miniature speakers.
Yep.
Even parts of the hard drive.
Huh. I had no idea. What else?
Electric vehicles, this is a huge one. They're powerful motors, the efficient batteries. They heavily rely on rare earth magnets, particularly neodymium magnets.
Right, you hear about EVs needing more minerals.
Significantly more. One source we looked at said an EV needs about 6 times the mineral inputs of a conventional gasoline car. 6 times. That gives you a sense of the scale needed for the green transition. These elements, neodymium, dysprosium, they allow for these incredibly strong yet small and lightweight magnets. Crucial.
So my phone, potentially my next car. What other big areas?
Medical technology is another major one. Think MRI scanners, they need powerful magnets. Certain surgical lasers, even some cancer treatments rely on rare earths.
Okay, that's critical. And then there's defense. You mentioned this is where the anxiety is really high right now.
Absolutely. This where it gets into national security nightmares, potentially. People often don't connect these obscure metals to military hardware, but the link is fundamental.
How so?
Our sources lay it out pretty clearly. The F-35 fighter jet, for instance. Reports say it uses something like 920 pounds of rare earth material.
920 pounds in one jet.
In one jet. And it's not just the F-35. It's the next-gen programs like NGAD, Tomahawk cruise missiles, Predator drones, hypersonic missile development, all rely on them.
What about things like radar and communications?
Crucial there, too. Advanced radar, like ESA systems.
Yeah.
Sonar for submarines and ships. Night vision goggles for soldiers on the ground. Even the solar panels and sensors on military satellites.
Wow. It's everywhere in advanced defense.
It is. And one assessment we saw was particularly stark. It suggested that a complete cutoff of heavy rare earths, the ones China really dominates in processing, could basically render parts of the U.S. missile and fighter jet fleet inoperable.
Inoperable. That's chilling.
It's not just about maintaining current systems. It's about our future defense capabilities, our technological edge. Access to these materials fundamentally shapes the next generation of warfare.
Okay, this paints a really alarming picture. These aren't just nice-to-haves, they're foundational.
Foundational is the right word. And their use extends even further into everyday things like energy-efficient LED lighting, high-quality camera lenses.
Wind turbines, too, right. I remember reading that.
Yes, massive wind turbines. They use powerful rare earth magnets in their generators. One source noted a wind plant needs 9 times more mineral resources than a comparable gas-fired power plant, again highlighting their role in the energy transition.
So they are literally woven into the fabric of modern life. Consumer tech, green energy, medicine, national security. Which brings us back to the core problem, China's dominance. The numbers are pretty stark.
They are staggering. China has spent decades strategically building up control over the entire supply chain. Mining. They control somewhere between, say, 60 and 70% globally.
Okay, that's a majority, but maybe not total control.
Well, wait. The crucial choke point is processing and refining, especially for those heavy rare earths, the most valuable ones technologically. There, China controls somewhere between 90 and, incredibly, 99% of global capacity.
90 to 99%. That's almost total control of the processing stage.
It's near monopoly status. And it doesn't stop there. They also control about 90% of the manufacturing of the finished rare earth permanent magnets, those things that go into the EV motors, the missiles, the smartphones.
So even if someone else mines the ore,
it often still has to go to China to be turned into usable metals or magnets.
And where does the U.S. fit in this picture? How dependent are we?
Heavily dependent. We import roughly 70% of our rare earths directly from China. And critically, the U.S. currently has no large-scale domestic facilities to process the heavy rare earths.
None.
Essentially none at the scale needed. So even the ore mined at the few U.S. facilities like Mountain Pass in California often gets shipped to China for processing before potentially coming back as finished products.
That's quite a cycle of dependence.
It leaves the U.S. incredibly vulnerable. It basically hands China a massive lever in any geopolitical or economic dispute, like the one we're seeing now.
It really drives home the economic hostage situation idea. It's one thing for consumer goods, but for defense.
It's a whole different level of strategic risk. And this isn't exactly a surprise development. People have been warning about this for years.
Right. And China hasn't been shy about using this leverage before, has it?
Not at all. The classic example is 2010 with Japan. There was a dispute over a fishing trawler. China detained the captain, and then they just halted rare earth exports to Japan.
What happened then?
Prices went through the roof, tenfold increase in some cases. It sent shockwaves through Japanese industry, and was a clear demonstration of China's willingness to weaponize these resources.
And we've seen more recent examples, too, leading up to this April 2025 move.
Yes, since 2023, we saw China gradually tighten controls on other critical minerals needed for tech gallium, germanium, antimony, often requiring export licenses for shipments to the U.S. Each move was like a little warning shot.
And then came April 4th, 2025. The trigger, as we said, was the escalating U.S. tariffs.
Correct. With U.S. tariffs hitting those high levels, China responded directly with these export controls on the 7 specific medium-heavy REs: samarium, gadolinium, terbium, dysprosium, lutetium, scandium, yttrium, and, crucially, the finished magnets. And shipments just stopped.
So it was immediate disruption. What do these controls actually entail? Is it a flat-out ban?
It's not technically a total ban yet, but it's a very tight control mechanism. Exporters now need a special license from China's Ministry of Commerce for these specific items.
And getting that license is...
Not straightforward. The process can be opaque, take months, and there's actually no guarantee it'll be approved. Initially, there was basically a pause in exports while they set the system up. It gives Beijing huge discretion over who gets these materials and when.
So they could potentially deny licenses to specific companies or countries, or slow walk approvals.
Exactly. It's a very flexible tool for applying pressure, and the threat of further actual quotas or even a full ban hangs in the air if the trade dispute gets worse. It could leave the U.S. and others scrambling for whatever supply is left.
And we heard reports, didn't we, about U.S. defense companies already being cut off.
Yes. Reports indicate at least 15 U.S. defense and aerospace firms are currently unable to get necessary dual-use goods, including these rare earths, from China anymore.
15 companies. That's significant.
It is. And as we discussed, if this escalates to a full shutdown of heavy rare earth exports, the consequences could be catastrophic, not just for defense, but across the board, rendering hardware inoperable, as that one assessment suggested.
Inoperable. It keeps coming back to that word. Okay, let's pivot to the impact across different sectors. Defense is clearly critical, but what about the tech we use every day? Consumer electronics.
The ripple effects could be huge there, too. Think about smartphones, laptops, TVs. They all need elements like neodymium, dysprosium for those magnets and speakers, hard drives, vibration motors, and for the screens.
So companies like Apple, Dell, they're exposed.
Definitely. They could face soaring costs for these components, assuming they can even get them. And significant shortages are a real possibility. We already saw prices jump for things like antimony when earlier restrictions hit.
Which likely means higher prices for us.
Almost certainly.
Yeah.
Companies will try to pass those costs on, or if they just can't get the parts, especially with lean, just-in-time inventories being so common, we could see production lines halted. Your next phone might be more expensive or harder to find.
Okay, not great news for consumers. What about the big push for electric vehicles? The green revolution.
That's facing a serious threat, too. Those powerful EV motors need neodymium magnets. These export curbs could seriously delay EV production schedules, push prices up, and potentially derail climate goals that rely on rapid EV adoption.
You could see factories in places like Detroit having to stop assembly.
It's a real possibility if the magnet supply dries up.
Right.
Remember that 6 times figure for mineral intensity? It really highlights how dependent the EV transition is on materials China controls.
It feels like a web, everything's connected. What about semiconductors, the chips and everything?
Yep, connected there too. Elements like gallium and germanium, which faced earlier restrictions, are used in chip making. These broader rare earth controls could further complicate things, undermining the big U.S. push to onshore semiconductor manufacturing.
So just as the U.S. is trying to build up domestic chip capacity,
This vulnerability could bite again, potentially leading to another chip shortage crisis down the line, affecting prices and availability of, well, almost everything with a plug or a battery.
so from our phones to our cars to national defense, it all traces back to these rare earths. It really sounds like the U.S. was caught, maybe not totally surprised, but certainly unprepared for the scale of this dependence.
There's an element of that, yes. The warnings were there, but the speed and scope of China's action in April really forced the issue. It's a stark wake-up call about the risks of these concentrated supply chains.
Which inevitably leads to the question, what is the U.S. doing about it? Is there a real scramble for alternatives?
There is definitely a scramble. It's a multi-pronged effort. The U.S. government has put significant money on the table, over $400 million, maybe closer to $439 million since 2020, using the Defense Production Act.
In the goal?
The stated goal is building a domestic supply chain, aiming for more self-sufficiency, perhaps by 2027, although that seems ambitious. The money is going into developing mining and processing facilities here in the U.S., but also looking at partnerships abroad, South Africa, potentially Brazil.
Okay, $400 million sounds like a lot. But compared to China's decades of investment in infrastructure,
It's a start, but it's a huge mountain to climb. These new facilities, when they come online, will likely only produce a small fraction of what China outputs. Plus, there's the geology. The U.S. just doesn't have vast reserves,
Right.
less than 1.5% of the world's total.
so domestic production alone won't fix it.
Unlikely to be the whole solution? No. But even having some domestic capacity, especially for critical defense needs like magnets, would be a strategic win. It's about balancing economics with security.
What about looking to allies, other countries with rare earth potential?
That's definitely happening. Active efforts to secure supply chains with Australia, which has significant reserves. Brazil, as mentioned, Ukraine, though obviously complicated now, even Greenland. And talks are apparently underway with Vietnam and Malaysia too. Diversification is key.
Makes sense. Are there options beyond just digging more stuff out of the ground, more innovative approaches?
Yes, and this is where some interesting long-term possibilities lie. Recycling is one big area, getting rare earths back from old electronics e-waste.
How viable is that?
There are companies working on it, like Phoenix Tailings, aiming for thousands of tons by 2027. Apple claims high reuse rates in some iPhones. But the reality is, globally, we recycle less than 1% of rare earths right now. The tech is tricky, and the economics haven't always worked out.
Less than 1%. Wow. Okay, so recycling needs major improvement. What else?
Research into substitute materials.
Yeah.
Scientists are trying to synthetically create things like tetranite. It's a magnetic iron-nickel alloy found in meteorites.
Making space rocks in a lab.
Sort of. Or developing completely new types of magnets, like iron nitride magnets, that don't use rare earths at all, but could be just as powerful using common elements like iron and nitrogen. Iron Magnetics is working on commercializing those.
That sounds promising.
It is. There's also research into pulling rare earths out of industrial waste, like the red mud left over from making aluminum. And some companies are just designing rare earths out completely. MAHLE has an RE-free electric motor concept. BMW's newer EVs already use motors without rare earths.
So designing around the problem. But how quickly can these alternatives, recycling, new materials, REE-free designs, actually make a difference? What's the timeline?
That's the catch. Many of these are promising, but still early stage or face hurdles in scaling up production cost effectively. And even traditional mining takes ages in the West. The average in the U.S. from finding a deposit to starting production, around 29 years.
29 years compared to China.
Where it can take just months to get permits and start digging. Here, estimates for a new mine are maybe 8–10 years minimum. Plus, we lack the specialized workforce and expertise that China has built over decades.
So long-term hope, but immediate medium-term vulnerability remains. It makes you wonder, does China face any downside to using this weapon? Are they totally insulated?
That's a fair question. Look, a full long-term ban would hurt parts of their own economy too. There's a whole ecosystem built around this industry in China: jobs, infrastructure, services. It wouldn't be painless.
But they still hold the trump card in a tariff war involving these materials.
They have what experts call an absolute advantage there, yes. Also, China's own need for rare earths is growing fast for their own EVs, wind turbines, tech. That might eventually limit how much they restrict exports, purely for strategic reasons.
And you mentioned they're also looking elsewhere, diversifying their own sources.
Yes, increasingly moving into Africa, securing mining rights or partnerships in places like the DRC, Kenya, Cameroon, Angola, Tanzania, often tying it to infrastructure deals.
So they're playing the long game, securing future supplies outside their borders, too.
It seems so. It diversifies their sources, potentially shifts some environmental burdens, though that raises its own set of ethical questions about resource extraction in Africa.
Absolutely. This isn't just a U.S.-China thing, is it? What about other countries, our allies?
They're caught right in the middle. Japan, South Korea, the EU, they're all heavily dependent on China for rare earths, but also allied with the U.S. It puts them in a very awkward spot.
We saw how China pressured South Korea before over the THAAD missile system deployment using economic tools.
Exactly. That's a precedent that worries many countries. And while China might look to places like ASEAN nations, India, or Mexico as alternative markets if they restrict sales to the West, those markets have their own limitations or dependencies.
What about India? They have reserves, right?
Fifth largest reserves globally. But their mining, and especially their processing capacity, is very limited right now. It's a huge potential opportunity for India, but also a massive challenge. They're exploring partnerships with the U.S., Australia, Japan, the EU to try and build that out.
It really feels like this whole rare earth situation is a perfect example of the bigger shifts happening in global power supply chains technology.
It absolutely is. It highlights just how interconnected we are, but also how vulnerable we become when critical supply chains get concentrated in one place, especially for strategically vital materials.
Okay, this has been incredibly illuminating, if a bit sobering. Let's try and wrap up the key takeaways for everyone listening.
Sure. I think the core message is this. The U.S. is deeply critically dependent on China for rare earth minerals. These aren't just minor components. They're essential for consumer tech, green energy, and vital national defense systems.
And China's decision in April 2025 to use export controls as leverage in the trade war, that wasn't a bluff. It's having real impacts and creates this potential for massive disruption. It really does feel like that economic hostage situation we mentioned.
Right. And while the U.S. is now scrambling, investing in domestic options, seeking allied sources, exploring recycling and new tech, the path to reducing this dependence is long, expensive, and complex. China holds a powerful secret weapon right now with its control over these elements.
A secret weapon that could jam the gears of Silicon Valley and the Pentagon.
Okay, so as we close out, here's a thought I want to leave with you, our listener. Really think about what this level of dependence on one nation for materials this fundamental means long-term. How is this going to shape global power, tech innovation, national security in the coming years? What are the real solutions? Is it just about finding new mines, or do we need fundamental shifts in policy and innovation, maybe even in how we consume technology? How do we avoid being permanently in this hostage situation?
Big questions, important ones. And what's our role as citizens, as consumers in this whole drama? Something to chew on. Thank you for joining us for this deep dive. We hope it sheds some light on a complex but absolutely critical issue.
Thanks for tuning in.
Until next time.